Okay, we're on page 649 at the top, letter A. The function r equals 73.3, the fourth root of m cubed, known as Kleiber's law, relates the basal metabolic rate r in calories per day burned and the body mass m of a mammal in kilograms. The table shows typical body masses for some members of the cat family. So we have a house cat. It's 4.5, a cheetah is 55, and a lion is 170. Part A. Part A tells us to rewrite the formula with a rational exponent. So we're going to take Kleiber's law, which is right here, r equals 73.3 fourth root of m cubed, and we're going to write it with an exponent. So how would I change Kleiber's law? R equals 73.3 times m to the 3/4 power. Next part B, what is the value of R for the cheetah to the nearest 50 calories? So we want to know what R equals when the cheetah, the mass of the cheetah is 55. So you're just going to put that in your calculator. You'll put 73.3 times 55 to the 3/4 power. And round that to the nearest 50 calories. So did you get 1,480.38? Yes. Okay. So if we rounded that to the nearest 50 calories, then we would get 1,500 calories. Okay, let's skip down and look at C. Find the ratio of R for the lion to R for the house cat. So now we're looking at the ratio of the lion. We're done with the cheetah. The ratio of the lion to the house cat. So let's go back to our formula, 73.3 m to the 3/4. So what would the R for the lion be? If I put 170 right there for the m.
47.
47? Yes?
What?
If I put 170 right here for the mass, for the lion, 73.3 times 170 to the 3/4 power. 47 point something? 0.1. Okay, what about the house cat? Let's put the mass right here for the house cat, 4.5. 3.1. What would be the ratio of the lion to the house cat?
15 times.
15 times as much.
Yeah, I got 3,000 something.
Yeah,
for the
I'll
line.
The first time I did it, I
Yeah,
got
they
3,000.
didn't multiply it by 73.3. That's why you get 47.1.
Oh, they canceled the 73. Okay.
Just cancel the 73.3 out, but
Yeah.
since it's in both.
That's
Gotcha.
what they did. Yeah.
Okay.
Yeah, I was confused.
So what would you have got if you multiplied it by the 73.3? The lion.
3,450.
3,450. And what about the house cat?
I didn't do that one.
226.47.
226. And if you divide that out, you should get 15. Okay. All right, any questions? All right, turn to page 650, your turn, number 8. Now this one's a little confusing. Because they call the things, they're too close to the same words. It says use Clobber's law, so we're still using the 73.3 m to the 3/4. Find the basal metabolic rate for a 170 kilogram lion to the nearest 50 calories. Okay, so let's find the lion to the nearest 50 calories if he's 170 kilograms. So what did we say the lion was? 3,450, right?
Yes.
Okay. That's the basal metabolic rate. Alright, then find the formulas predicted for a 70 kilogram human. So now we're looking for a human that is 70 kilograms.
1,774.
1,000, try again.
773.
Try again.
1,773.
To the nearest 50?
1,008.
There we go. 1,750.
Oh,
Okay, so that is the basal metabolic rate. Okay, here's the part that's kind of confusing. Use your metabolic rate results for the line to find what the basal metabolic rate for a 70, well, that's what we just did, for a 70 kilogram human would be if the metabolic rate and mass were directly proportional.
omit.
I think I said this wrong.
When it's
Typo.
Okay. So we're going to take the lion to the basal metabolic rate. See, anyway. Human, how much for the human if they have a 70 basal metabolic rate? I think this should just be, that should not be there.
1750.
Wouldn't it be the same?
1750.
Cross multiply. We're not looking for the basal metabolic rate, we're looking for the metabolic rate. So that would be 170x equals, what is 3450 times 70?
241,500.
241,500?
Yes.
Divide that by 170.
1,000.
Okay, it's like 14, 20, 58 or something like that. 1,400 would be rounded to the nearest. I think this word right there should not be in there. And then it would make sense. But you just set it up as a proportion.
So this is supposed to mean, this is saying that if you weigh 70 kilograms, you should eat 1,750 calories a day?